I know I had some previous videos about using NX. They're kind of old, so they're using older versions of NX and Strength Wizard, which has been supplanted mostly by advanced simulation. Okay, so I'm kind of doing an updated video, and actually I'll go over a couple of more things that I didn't cover in the first one. I'll go through the basic steps in doing an analysis. Granted, I'm going to skip a lot of details. You'll have to kind of explore those on your own. We can talk more about those in class. Talk a little bit about the ideas of the file structure, which can be a little confusing. I'll do a simulation. We'll do some part simplification for the model on using an idealized part. And then we will also do a design change, and we'll go through how the associativity in NX facilitates doing design changes, and your finite element models get updated relatively quickly. Okay. All right. So let's open up a part. The part I'm going to do is this cassette adapter, which actually I changed the directory, so it's going to take a little while for it to think. Actually, let me close this out. I'm going to open a different version. Where is it? Cassette adapter. Okay, so here's the part. It's called cassette adapter with a couple of vowels dropped. .prt. And it's a component that we use on the Eco Marathon. Okay. Let's turn off our Facebook warnings. So it looks something like this. So what happens here with this part actually is this sits on the rear wheel of basically a bicycle wheel and transmits a torque from a chain ring through to the hub of the rear wheel. It puts the torque onto the wheel. Okay. So we'll put some forces through these holes and fix some of the spline surfaces to simulate that torque load. All right. It's also got a lot of features on here that I really don't want to put into my finite element model, like these chamfers and some of these fillets in here, and we'll talk about how one removes those and makes your simulation go a little easier. Okay. All right. So before I do that, obviously the first thing we go into advanced simulation. So under start, there's the advanced simulation icon. Now I know again from the video the resolution isn't such that you can really see all the icons, so you need, you might have to pause the video and try to find it on your own, but so it goes. All right, so when we go into advanced simulation, you can see the windows change a little bit. The icons obviously change on top. The most important thing to note is you have a couple of, instead of having the usual model and assembly view, you've got these simulation navigator and post-processing navigator. So post-processing navigator obviously is after we get results. We'll look at the results using the post-processing navigator. But to develop the model, we want to use the simulation navigator. So here is this the cassette adapter part. Okay, and here's the status of it and all, and it's all good. So the first thing we're going to do is create a new finite element and simulation. Okay, so if you right click, you can get new FEM and simulation. So let's do that, and now some windows pop up. All right, so the first window, it's kind of critical to look at this stuff. You can see it's creating some new files, cassette adapter underscore fem1.fem and cassette adapter underscore sim1.sim. All right, this is creating some new part files for the simulation, an FEM file, a sim file, and it is also going to create what they call an idealized part file, cassette adapter.fem underscore i.prt. So this is actually a part file. The FEM file is one that has a mesh, and the sim file has all the other associated finite element data like boundary conditions and load cases and whatnot. All right. Okay. You can also pick the bodies, but in general, all visible is a good command. If you have an assembly, you can change that. And we're going to be using NX Nastran, and it's going to be a structural analysis. So we'll hit OK. And now it's going to generate those files. Okay? And you can see down here in the simulation file view, I don't know if I can pull it over yet, those files are kind of brought down into a tree here. All right? All right. Let me talk a little bit about the file structure. Okay? So I made a little slide just to show you what's going on here. So it seems a little confusing at first, but it's actually very useful. So you have to remember with NX, the philosophy behind doing NX advanced simulation is it wants to really keep the associativity in your workflow between your finite element model and your CAD geometry. It does a good job of it. And in an ideal situation, keeping that associativity is awesome. That means when somebody makes a change on a design, that it can easily automatically update your finite element model and get new finite element results. So it's wonderful. The problem is it does kind of limit you in some of the things that you can do when you fully disassociate the model from the CAD model. And so when you're doing more, sophisticated models or high fidelity models, you'll probably want to not work in NX advanced simulation, work in something like HyperMesh and solve it in Abacus or LS-DYNA or Nastran separately. But you lose this associativity. So there's this price you pay. You have the benefit of the associativity, but you lose a little bit of the flexibility, or sometimes it feels like you have to kind of jump through some hoops to do things that you want to do to maintain the associativity. You actually can break the associativity completely, but once you do that, in my opinion, you might as well just use another preprocessor. Okay? So here you have the original design part, widget.prt. Okay? In our case, widget is cassette adapter, right? Once you create the new simulation and finite element file with an idealized part, it generates 3 more files. Another part file. This is the idealized part file. So initially it's going to look just like the original file. It'll have no differences. But what this allows you to do is remove features that aren't relevant for your finite element model, and it'll make the mesh problematic to generate without changing this design model. So all the designers or the engineers working on the product design don't see the fact that you removed some small pinholes or a fillet or whatnot, right? But the associativity is still maintained. So if somebody makes a change on the original design part, you will be notified of that when you open up your idealized part file, okay? And you kind of click an update. We'll show how that happens, and the geometry already automatically updates, and it will automatically update the finite element mesh, which is kept in the FEM file, and also the boundary conditions and all that sort of stuff in the simulation file, okay? So it's important to keep track of all these. And the other thing is it's important to keep track of these in the context of this tree here, because sometimes, depending on whether you're looking at the FEM file or the sim file, you'll get some different icons popping up here. So if you are trying to make the mesh and you don't see a mesh icon up here, it's probably because you have the sim file open and you need to open up the window with the FEM file. Likewise, if you want to apply a boundary condition, you don't see those icons, it's most likely because you have the FEM file open and you need to open the sim file. And I'll show that later on, but we'll talk about that. But it's something that can be really frustrating and confusing at first, but it's got some good benefits to it. Okay, so we've created the new simulation, the FEM file, and the idealized part file. Now we're going to create a solution. Okay, so it's one solve. It's like one finite element solution. Okay, so it's going to use linear elastic static solver 101 in Nastran. Keep everything the way it is. You can, honestly, you can run different types of analyses in here. Like again, still like sometimes typically I've done modals through here, but anything more sophisticated than that, I usually find it's easier just to go through another preprocessor. Okay, so we'll keep it at solver 101. Hit OK. you can change the executive control section, the solver, all that sort of stuff. Okay, so we hit OK, and there we go. Now, as I was mentioning before, it's kind of important to get used to being able to move back and forth between these different modes. So right here, we're looking at the FEM file, all right? And you can see that the icons located here are like the ones associated with meshing. Now, if we go to the sim file, let's click on that. Now you can see what happens. There's almost no change, but what you see is the icons change to allow you to apply different boundary conditions. And lastly, you can go to the idealized part file, and it'll talk about how to promote the body so that you can maintain the associativity. Okay, but let's not do that yet. Let's go back to let's go back to the FEM file. There we are. All right. So, take a moment to look at that. Get used to moving back between the different windows. You can also do that through window up here. There's the sim, the part, and the FEM file, and the original part file. So all 4 files are here: the original design part, the idealized design file, the simulation, and the FEM file. So once you try to bounce back and forth between all those. You actually have to save all of them separately, so that can get a little annoying, but it's a good thing to try and do. Okay. So what can we do next? Let's go through and just set up a real simple model on this. But before I do that, I'm going to look at this and I'm going to see that there's definitely features in here that I do not want to show up in my finite element model. Okay, so I'm going to talk now about how you suppress these features in the idealized part file and not change the design file. Okay, so I'll probably stop after that and then set up the boundary conditions. If you want to just do a real simple model and look at the boundary conditions, you can look at my older video. It doesn't do any of this associativity stuff. It just kind of plows through a simple plate model, and it doesn't get into this idealized part stuff. Okay, so all right, let's now go through and kind of simplify the part a little bit. So when we do that, we have to go to the idealized part. So here it is. Wait, where is it? I'll go through the window. Here's the idealized part. And now you'll get this warning. It says, before you can modify geometry in this part, blah, 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 you must promote or wavelength the geometry. I'm not sure what wavelength exactly does. I always do promote. You do promote, okay? So you can just hit OK. The body isn't promoted yet. But when you promote the body, it basically sets up the associativity. Okay, it allows you to make simplifications onto the idealized part and not affect the top level part. So to do that, there's this icon here. I have no idea where they came up with why this icon looks the way it does, but so be it. It's this icon second to the left. It says promote a body to the level of assembly. Okay, so we click on that, and then you have to select the body. For us, it's, there's only one body here, so we pick that, and then you hit OK. You have to do that, okay? That's the way it is. You don't really see much change, but that's the way it goes. Now you can suppress features. Okay, so let's first notice that we got these like annoying little chamfers here, okay? So I'm going to want to get rid of those, all right? So to do that, there's a couple of things that it lets you do here. So you can edit features, you can suppress features. You can also defeature geometry. That basically just removes those features, so it works quite good for chamfers and small holes. And you can split the body. Split the body is good for symmetry. So this part does have symmetry, although when I load it, it's not going to be symmetric. But you could split it in half and apply it. I guess you can apply anti-symmetry boundary conditions on it. Another useful one is divide face. So if you want to just put boundary conditions on, say, half of this hole here, you can split that hole. Basically, it'll split the surface, and then you can apply boundary conditions on half of the surface, okay? All right, so we want to defeature some of the geometry, okay? So you can pick the hole and remove those, but what I want to get rid of are like these little chamfers, okay? And if I go through and I pick them, just pick this one on this other side. Oops. I always get it. Picking is always annoying. Let's do it again. Defeature geometry. Let's pick that one. Maybe I can only do one at a time. I don't know if I can or not. But I think, okay, so let's just do that. And then you hit the green check mark. And what happens is you can see that chamfer has now disappeared. All right, chamfer's gone. Now, if I go to the original part model, the cassette adapter part, go through window and pull that up, you'll see that those chamfers are still there, right? But I've gotten rid of them in my idealized part file, okay? So I'm going to go through and remove all of those because they are quite small. Oops. No, idealized geometry. What am I doing? Where is it? Promote. Defeature geometry. Right? I'm going to go through everyone on this side. If you want to, you can always do an undo or something like that, so you can fool around with trying to defeature different features and see what it does. I mean, this one's probably the most useful one. And I probably should. Pushing my luck selecting all these because I'll probably mess up and select the wrong one and have to start over again. Yep, there we go. Control. What is it? Control? I never know how to do this. I never know how to. I should know how to select, deselect. I know this is boring. Okay, you know what? I'm going to just do this again. Let me go. This is why I hate doing these things. This is why I never do this stuff in class. Okay, we got that one. That one's the one we got rid of. Oh, we got rid. Wait. Oh, I got rid of all those. Oh, those went away. Okay. But I didn't get this one. Okay. All right. I think those are all gone. Okay, that's good. Another feature. I'll keep. I guess I'll keep these chamfers. They're pretty big, but one that's definitely kind of annoying there's all these fillets in here. Now, one could argue that I probably should keep those because of the stress concentration factors. But I'm going to remove those just because, well, I'm going to do it just because for the exercise. So we'll pick some more of those. So you can pick that thing. Let's pick all the fillets. I should use my little 3D mouse. That one. In fact, you can probably, we'll only actually fix a couple of these to do a worst case scenario, and I could probably keep the fillets out of the ones that I am not going to use the fixed constraint on. But let's get rid of all of them first. Okay. There's an awkward silence. That's terrible, isn't it? I should tell some jokes while I'm doing this or something. Okay. I think I almost got them all. I think that's all of them. All right. Let's defeature those. Yeah, I think you can always go back and undefeature those to use a double negative. And so there you go. Now there's square keyways, right? Okay. And you can do that with other things. I think, like, let's save. I believe you could probably also defeature some of these holes. I'm not sure if you want to do that or not. I mean, you definitely don't want to do that, but let's go through. You could pick that, and there goes the hole, right? But I want to keep that hole, so let's bring it back. And I'm not sure how you defeature them, but idealize geometry lets you pick some general features, like you could remove the splines. I think that's probably pretty good. I'm not sure if there's anything else I want to remove for now. I think I can get enough mesh to get these fillets on here. This one's not going to do anything. One could argue I could probably get rid of this one. So let's get rid of this one. It's not really going to do much. And, well, this one's constrained, so I'll leave that one there. Okay. Okay, so there we go. So now we have a simplified geometry. This is our idealized part. Again, if you look at the top level part, those little features are still there. Well, let me mention another one. I don't know if I'm going to do it on this model, but well, okay. Let's say, for example, what I'm going to do here is I'm going to put on these holes bearing forces that model the torque, okay? And then I'm going to fix some of these faces. But let's say I want to do a worst case scenario. Let's assume that maybe the, in a bad situation, only a portion of this face really has the fixed constraint. So let's say, like on this point here, this face here, I only want to put the constraint on a part of it. I can't really do that now because it's one surface, but that's where we would use the divide face. So the way we can do divide face is, for example, if we put a cutting plane here, that'll allow me to divide the faces with that plane. So let's put that first. Let's first insert a datum plane. And I think I can just do an offset at distance. Let's pick that. And maybe not that far, but maybe 1 inch, half an inch. Yeah, let's assume that it's the splines are only gauged out at this point and not inside here for some reason or another, okay? So there we go. So now I can go through and split those faces, right? Divide face. And let's say I want to divide this face. And here's the dividing object, okay? And I hit OK. And now you can see the face is divided. So if I were to go in to, say, the simulation model, boy, let's see if I can find that face now, and try to apply a boundary condition on it. Where did that face go? I wonder if I have to update it. Oh yeah, you know what? I have to update it. Okay. I'll be able to put that force on. I mean that boundary condition on just part of the face. All right. The reason why I don't see it here is actually the file has an update pending, and the update is all my simplifications due to my idealized geometry. And so you can see the fillets are still here and everything. And I have the sim file open. So let's update it. And I always forget how to do this. It's like you have to double click. And there it goes. It's updating it. And now, yeah, you can see the chamfers are gone. And I should be able to see that surface somewhere in here, that split surface, wherever it is. I don't know where it is. There it is. See? So there's the divided face. And so now if I wanted to put a constraint just on that face, I can just pick that, okay? So that's really useful. A lot of times you don't want to put the forces or the constraints on the entire face or the entire surface. So that allows you to pick a region, okay? You can draw little sketches to do it or other things, okay? So that one's quite useful as well. Those are the two most common ones I use. You can look through the other ones, all right? You know what I'm going to do? I'm going to stop the video now and take a break. And then the next video, we'll take this idealized part with the simplified geometry and set up the first finite element model, okay?